So without further ado, I invite Professor Cleall to share the screen and give the presentation. Thank you.
Thank you very much. Oh, just waiting for permission. I think you have to stop sharing.
Yeah.
Okay, so hopefully that's coming through to you.
Yeah.
Well, firstly, many thanks. But two things. One is many thanks for inviting me to the series and to present, and then secondly, many thanks for organising it, because it's quite an effort to organise these things, and it's been going on for quite a long time now, and really first class, really very valuable for everybody concerned. I'm more a watcher of the videos, but they're really good and very helpful. It's like being able to drop into a conference and just pick up the keynotes. So it's really good. Okay, so also many thanks to everybody else that's managed to find the time, either this afternoon or this morning, depending on where you are. And as you've heard already, I'm from Cardiff University. I know that you heard from Feijin a few months ago, a few weeks ago. So it's nice that I'm continuing the Cardiff thread through the series. So this is the title. It's quite a lot of words, I realised once I'd actually typed it all out. But basically, what I wanted to do today was to talk a little bit about landfills, and a little bit about the fact that many places we've got lots of landfills, and sometimes we don't really know what's in them. And thinking about ways that we can use data and information that we've already got to inform our understanding maybe of what's in the landfill, and then to look a little bit about, well, what's happening in terms of leachates, and obviously that's driven by what's in them, and then finally to very briefly touch on the ideas about that we're starting to formulate here about future repositories. What can we do in the future? So I think that it's worthwhile bringing the acknowledgements to the front, because often they get left to the end and people aren't listening then. So hopefully you're still listening at this point. So I want to acknowledge my colleagues in Cardiff. Devin and Michael are both academics with me in the school. Also Muaz, I think, is on the call, is a PhD student with us and is now a research associate with us. And also Mr. Stephen Warwick, who's a PhD student who's just submitting any day now. And some of the work that I'm presenting today is from his studies. Obviously, lots of other people that I've worked with over the years that have fed into this work. Much of the work that we do is only done because we get funding. So just to acknowledge the funding councils, we've had some funding from the EREF in the States as well. And of course, and actually most importantly in these kind of projects is people from industry giving us information and insight and understanding of the problems. So the presentation plan, really what I wanted to do is just to give a little bit of a preamble, a little bit of background about kind of what we're up to and why, and then start to look at landfill content, a little bit of history, fairly UK specific, but in some sense is quite generic. Then starting to ask the question, well, what is in my landfill? If I've got a landfill, what on earth is in there? And if you think about that question, can we answer it by just sampling? Or can we model some things? Can we try and understand? Can we use data to tell us? Then is it all rubbish? Because when it went in, it was rubbish. It was considered to be rubbish. It was thrown away. Is it still rubbish? Are there things that we can think about extracting? As I mentioned a moment ago, we'll talk a little bit about leachate development, and then also looking at towards the future. What might a repository look like in the future? So in terms of the preamble, what I wanted to say really was a little bit about the group in Cardiff that we a number of years ago started to think about kind of the different expertise we had in the team and what kind of problems we could look at. And one thing that we realized was that there was a, at that stage, maybe 15 years ago, there was, resources were becoming scarcer and people were starting to get concerned and starting to think about resource recovery. And we started to think about, well, where are resources? And we were looking at landfills being, sort of places where we were depositing a lot of waste and thinking, well, how can we extract those? And what we'd seen is a lot of kind of active mining in the UK over a long period of time, and that had largely come to an end. So we had a lot of waste repositories with lots of waste from different places that I'll talk about in a moment. And we started to think about how we could maybe get those resources back without undertaking what you might call sort of active mining in terms of digging it all out and reprocessing it. So we started to think about in situ processes, and could we apply in situ processes to start to extract resources that are within these waste masses. So that came about kind of like a roundtable discussion, and then we started to formulate research plans around that. And we've had a number of projects looking at those kind of things, and really that's kind of led to this area of work that we've been focusing on. And really what we've been starting to look at is what we might think about kind of the Anthropogene ore deposits. So these are ore deposits that are being formed by us through our activities, and largely these are really, if you think about it, we've been placing huge quantities of waste, and I'm going to talk quite a lot about this one here, municipal waste. So, but actually, there's an awful lot of industrial waste, metallurgical waste, and mining waste as well. And what they've got in them is actually quite a lot of value resource in them. And we've been putting those into the ground, or in some cases on top of the ground, but largely in kind of inert sort of piles, which we don't do a lot with. But effectively, when we were putting those into the landfills, if you like, we were disposing of them. We were kind of putting them to one side and not thinking about coming back to them ever. But actually what we've effectively done is to put those resources into some form of storage. And what we've been storing there are things like metals and nutrients, quite a lot of bulk materials, quite a lot of energy is embodied in the waste, whether it's in terms of biomass or polymers. And then, of course, the other thing that we've done is quite often we've used that land, and we've kind of like stopped that land really being used for any other development. So we've basically kind of put those things into storage. And if we think about where we are now in terms of the circular economy, then this kind of waste disposal is really a leakage from the circular economy. So we need to start to think about, well, can we prevent that leakage? Can we get those resources back into the economy to make them available again? So as I mentioned, the main focus is on municipal waste, but many of the things that we're thinking about here kind of relate to the other wastes as well. So some questions that we might start to ask ourselves, and what we were starting to think about when we were thinking, well, can we get value out of a landfill? The first question is, well, what's in these repositories? What have we actually got? And you think that we know the answer to that, but often we don't. More often than not, we don't, in fact. There's no nice government database that says, okay, well, in this landfill, there's all this content. So we then need to think about, well, how can we find out the answer to that question? What information do we have that allows us to determine what might be in that particular landfill, and also what form is it in? Then we can start asking the question about, well, is there really any value to be found in them? Is there value in these landfills? Is it really a untapped resource? We need to understand how they're changing. So if we know what's gone into the waste, into the landfill, what waste's gone in there, well, what's there going to be if that was done 20 years ago? What's there going to be there? And then finally, this question, well, okay, well, for example, in the UK, we're really winding down our kind of landfill activities. We're not really building any new ones. So what's the future for these repositories? Where are we going to put these wastes that maybe we can't incinerate or store dispose of in some other way. So these are some of the questions that we're kind of asking ourselves when we're thinking about the research questions that we should be posing. Okay, so a little bit of history. I'm not going to give a hugely detailed review of waste disposal in the UK, but it is useful to understand what's happened in the UK. And it's not particularly just because I'm from, well, it is because I'm from the UK, so I've got the information and this is what we tend to study, but actually what's happened in the UK is being repeated in many other places. So we've kind of started from a period where there's been generally unregulated waste disposal, kind of, and effectively sort of pre-1850s, then basically what the city sort of managers were worried about was streets getting dirty and there being, you know, sort of just mess and muck on the street. So we had processes in place. People were paid to take the mess away and just get rid of it. It was unregulated. So as long as the streets were relatively clean, nobody really thought that much more about it. And of course, there was a lot fewer people there, and there's a lot more area where you could kind of dispose of things without it impacting things so much. But as the industrial revolution took hold, and really the size of cities became really quite large, then, you know, people started to really worry about the health impacts, and that wasn't really well, people might get ill. It was people are getting ill, significant problems. So regulation started to come in, and if we look at municipal waste, you know, in any country, then it's largely driven by, you know, what regulation is in place and what does it drive people to do. So in the UK, then we had what we call the Public Health Acts, and really what that started to do was started to say that we had to have, you know, refuse collection and disposal, but it didn't really say how you did the disposal. So the landfilling was still uncontrolled. It was basically dump it in a hole that you could find. So as time goes on, that kind of situation remains largely the same. Probably a little bit more control gradually comes in until we get to after the Second World War, where there's a relatively marked kind of like a change in activity, in the sense that it was quite austere times. There wasn't a lot of money. There was rationing in place. And that's important because it, you know, from a psychological perspective, if you're rationed, then you really don't waste anything. So very little is thrown away because you're very concerned about where the next bit's going to come from. So there were low incomes, restricted supply of resources, and largely speaking, the waste that people produced from a household was ash. And this is great ash. So this is basically, in all those houses were fires, and they would burn coal, but they would also, which they would buy, but they would also burn any of their waste that they could get value from in terms of energy. So very little regulation, and probably, you know, the records show that about 90% of the waste that came out of households went into landfills. So the language is quite instructive about how people talk about waste and waste disposal. So in those days, people talk about the ash man, and they were called the ash with two reasons. One is it was largely men doing it, and the second is what they were collecting was ash. They really weren't collecting what we think about in terms of municipal waste. It was largely ash, and what they collected, and even for me, sort of in the 1970s and 1980s, we talked about the dustbin. You know, it wasn't the rubbish bin; it was the dustbin, because it's what was in there was the dust from the fires. So, and that kind of situation really carried on for maybe 15 years or so. So there was, you know, really quite restricted production of waste in the sense of what it was formed of, largely ash. We get to the 1960s, people start to get a bit more money, incomes increased. Significant change was that there was a national gas grid introduced across the whole of the UK. Not universal coverage, but large proportions of households now didn't need to have fires. They could have a gas boiler. So what that means is that we weren't producing the same levels of ash. So we start to see a lot more paper and card appearing in the waste stream. As we get to the end, towards the end of this kind of era, towards the sort of 1980s, 1990s, then what we found is that the regulations start to change. So early on, the Clean Air Act started to impact. When we placed the waste, we couldn't affect the air, but really, as towards the end of this period, then there's quite a big policy shift in terms of, up until that point, the policy was dilute and disperse. So a landfill would be somewhere where you put your waste in, and it was designed so that the contaminants could gradually leach out of the landfill. So in effect, kind of treat the waste by just taking, sort of low levels of pollution going out into this huge, what was perceived as this huge environment. It wouldn't make any difference. So by the end, when they become inert, then everything is gone, and that changed very significantly, sort of in the late 80s, where it was considered that was crazy to do that. What we really need to do is to contain. So we had very much moved to a policy of containment. So which is where we put all the liners in and keep everything in there, and we just store it and almost concentrate. Which, when you've got a landfill that's working well, is a great idea, but of course they have a lifespan, and that when the barriers start to break down, then that can potentially cause you problems. The other thing that happened is that the European Economic Community, of which the UK was part of at that point, introduced what they call the polluter pays principle. So effectively, if you cause pollution, then you're going to have to pay for it. So if you're a landfill owner, or you were putting waste in the ground, if it was going to cause pollution, you were going to have to pay for the problem. So they sat up and listened, because they didn't want that risk or liability falling on them. So we then get to the 1990s, and again we have quite a big shift in terms of the kind of social activity. We have what was called hyper-consumption. So this is where effectively people buy stuff they don't need, and replace things that haven't broken or worn out. So there's quite a lot of money available. So quite a lot of waste is actually the products that have still got life in them effectively, but people want to replace them. What we start to see is waste electrical and electronic equipment waste going into the waste streams. So we start to produce these. They start to, in terms of the waste streams, they're there. How much of that is actually put into a landfill is another question, which is a little bit, because people tend to hoard that kind of thing because it's quite valuable, it's quite expensive, so people don't tend to just dump it. They feel as though they ought to keep that value in some way. So there's a lot of that, sort of wee waste is stored in people's drawers, in people's loft, in people's garages. The other thing that happened in terms of landfill, there was a landfill tax that added. So basically, people were charged for placing. The government charged a landfill operator an amount per ton, sort of £80 per ton. So that then stops you wanting to put anything in a landfill. It kind of restricts, inhibits that kind of usage. And then probably from about 2000 onwards, then we started to think about, well, actually municipal waste is a resource. It's not really a waste, it's a resource, and we need to think about what we're doing with it. Quite stringent regulations really pushing us to reduce waste, recycle, divert it to other places. And the other thing that happened then is we really started to record quite precisely what was placed and where. So we start, things that have been landfilled since about 2000, 2005 maybe. We get a much clearer idea as to what's in those landfills. And also we start to realise that there's real value in the land, and also there's a kind of a spatial thing that's going on here that I'll mention in a moment. So effectively, what we've got there in terms of landfills that are kind of modern landfills in the UK, there's these kind of 4 epochs or 4 kind of periods where fairly distinct kind of behaviour, which will influence what's in those landfills. So we've got a evolving position in the UK. So basically, in about 1960, about 90% of waste was going directly to landfills, and really we've moved now progressively to waste reduction, recycling, a lot more incineration. So the number of landfills in the UK is really dropping down. At the moment, there's, well, in 2017 there was about 300 or so open landfills that still had capacity to take more waste. So relatively low numbers. But what we do have is a really large inventory of closed landfills. It's kind of like a legacy problem, if you like. The geographical thing I was kind of alluding to a moment ago is that often these landfills are inside urban areas, and you wouldn't build a landfill inside a city, but where you build it is on the edge of the city typically, or the edge of the town. But what's happened in the UK, it's the same as anywhere else. Then the towns have got bigger, or the cities have got bigger. So those landfills, when they were originally, they were on the outskirts, and now within the city. And what that means actually is that the value of that land has started to increase significantly. So what that means then we probably need to take that into account if we're thinking about whether there's value, because that land value is likely to have gone up. And this is where we start to think about the potential for these landfills to be considered as a resource, and the kind of like the term that's come up is landfill mining. So can we take that waste and do something with it to extract value? One of the obvious things to do, if you've got things in there that have got calorific value, then we can just incinerate it, dig it up and put it in an incinerator and get the calorific value back out of it. That's relatively straightforward thing to do, although it requires a bit of energy in itself to actually dig it all up. The other thing that we might want to do is to kind of like waste to materials, you might think about, so basically extracting those components that we think are of value, materials of value. But often actually the thing that kind of drives whether landfill mining actually happens or not is the land use. It's the fact that you can liberate that landfill, reprocess it and make that land available for development, and that's often what makes the difference. And so as with most engineering, we can understand the processes really well and all those things, but actually it's the economics of it that tend to drive whether it happens or not. So relatively complex economics, there's quite a few different factors that we need to take into account if we're going to assess a landfill and decide whether it's economically viable to do this. And really, the economics can't just be about profit and loss. They should also sort of take into account other things in terms of sustainability, the other pillars. So it's not just the economics, there's the environment and the social pillars as well that we need to take care of. So if we think about in terms of value, then I guess we tend to get drawn, like a magpie to a shiny thing in the corner. We think, oh, that landfill's got value in it. There's precious metals in there. There's something in there that we can sell and make money from. Also, there's kind of like a negative value associated with many landfills, and this is to do with the potential for pollution or actually maybe ongoing pollution, and because of that, the requirement to manage them and mitigate the risks associated with that. So we've got these kind of factors here. So the fact that we've got a landfill is causing us this kind of negative value. Someone's got to bear that financial risk or cost. The other thing that sometimes we don't think too much about is that actually quite often landfills, and maybe not always for municipal waste landfills, but certainly for other waste types, then placing large volumes of particular materials in a environment actually causes the ecology to change. And what that means is quite often you get rare flora and fauna growing on those sites. And it may be the only one of 5 sites in the UK that particular plant grows. So, that has a value. It's hard to put a number to that in terms of money, but it does have a value, as a cultural value, a ecological value. Also, there's a cultural value to many of these things. People quite like their landfills in a funny sort of way. When you start because once they're capped and finished, they tend to be turned into parkland. In the UK, I'm not sure if it's the same everywhere else, but in the UK, almost every family has a dog at the moment, and they want to walk their dog somewhere. In the middle of the city, there's not so many places, but that old landfill has got, is now a park and is actually perceived as having real value. People don't want that all dug up and destroyed and built over with more houses. In the southwest of England, then there's lots of old mine workings down there, tin mines, and they're part of the area, and people go down there to see that coastline with those old buildings on there, that's all part of the history. So there's a value associated with that. So if we go in there and we just strip out the landfill, then we lose these things as well as gaining maybe these benefits. And of course, the other thing is going to cost us money to extract the resource, to actually process it. So we need to take all these things into account and see whether, when we kind of add all the positives at the end, does it actually make sense for us to do this, not just from an economic perspective, but also from these other perspectives as well. So quite a difficult question to answer, actually. And when you start to take all these factors into account, what we see is that there isn't an awful lot of landfill mining going on. Okay, so the question that I kind of pose next, well, what's in my landfill, or what's in my landfills? And actually, as a regulator or a policy person, then you're not interested in individual landfills, you're interested in your inventory of landfills, really. And we can think about a few kind of scenarios where we might be asked this question as engineers, and we can think, in the UK, where we've got recorded deposition, so that's kind of like post 2000. But wherever the country is, there'll be some landfills where there are, what's been placed has been recorded. So you've got clear records of what's placed, where, and when. So we kind of know the story. We monitor things. So maybe monitor sort of gas emissions. We monitor the leachate. We don't tend gas emissions, we sometimes monitor these because we're interested in how much there is, in the sense of, can we sell it? We put it back into the grid, or can we burn it and get energy? But leachate, we tend more to be focused on, is it causing environmental problems? So what we're kind of monitoring here is not really, is there value? It's more to do with, well, is it going to cause a problem? What it does is we've got really quite good records of what went in and what's coming out. So in terms of mass balance, we can really have quite a good handle on what's going on there. We need to understand the evolution of the waste content, and as time's going on, that waste content is changing, so that evolution is changing, and we'll touch on that a little bit later. So in terms of a problem, if somebody says to me, what's in my landfill, and they say, but placement started in 2002, then I say, well, we can probably nail that down fairly well, because we've got pretty good data about what's gone in, and it's been recorded at an individual landfill level. So it's a well-defined problem. The only thing that we might have a challenge with is, well, what's happened to that waste whilst it's been placed there? Do we understand those processes well enough to really be able to predict that accurately what's now in there? And that's a bit more challenging. Okay, so a different scenario, bit more difficult for us to deal with. We've got a landfill, and we didn't really record what went in there. So there's no real clear records of kind of like the waste placement. We will have data though about where it is, because we've been asked to look at that landfill there. We'll know the area of it. Often we'll know the historical topology of the land, so we'll kind of work out the volume. And also there's normally records about when it was open, when it was active. So we can normally establish those things relatively well. We may well have some monitoring of emissions, depending on how old the landfill is. Then there may well be some data about what's emitting from these landfills, or maybe we'll have data that says this landfill is no longer gassing because we've checked and we've not found anything, which will tell us something about its state. So one option we've got there, let's go in and take some sampling, but the trouble is that this waste is really heterogeneous, and if you go in and take small samples, then you're really very, very tricky to get good answers. So we've got a problem here. I'm trying to answer this question. Limited or maybe no real data that's kind of particular to that landfill. So this is really quite a poorly defined problem. So as an engineer and as a researcher, this is the bit that's interesting, really. This is where we want to look at what's happening. So what can we do? What options do we have? Should we model it or should we sample it? I guess is some ways you could term the question like that. So in terms of sampling, then a few problems related to it. It's expensive, it's invasive, so you start digging it up and kind of exposing sort of pathways. It tends to be quite a slow process, and personally I think this is there's a real question mark as to how reliable it is. Because if you start to look at it statistically, to get really reasonable levels of confidence as to what's in that landfill, then you really have to have really quite extensive surveys done. You need to do a lot of sampling. And it has to be very well controlled as well, because the wastes are all different, and different components of the waste remain in different forms. And particularly the thing that I'm thinking about here is plastics. They tend to stay the same form. They don't break down in any way. And when you sample, you tend to get more plastic out than you should, because I think what happens is when you put your sampler in, you tend to pull plastic from the surrounding volume. And when you look at the data of what comes out, then often the plastic content is much higher than you would expect it to be. So not so easy. I mean, sorry, that one thing I should say, full exclamation is the answer, really. If you really want to know what's in there, dig it all up and measure it, and then you will get the true answer. But obviously that is landfill mining. You've done it by that point. Okay, so what other options we've got? We can look, what I talk about is upstream. So we can think about what's coming, what information have we got about what's gone into the landfill, and actually, if we start to think about generation rates and disposal methods, if we've got a good handle on those, then we're going to have a pretty good idea as to what's in the landfill, because if we didn't put it in there, it isn't in there. So we've got actually quite good records of those. Probably is they're kind of dispersed all over the place. And then the other thing that we can do is maybe look downstream, see what's coming out. We can consider the emissions. That may give us a good indication, in terms of methane production, as to what phase the landfill is in. And one thing that we considered is maybe the leachate has a fingerprint that we can identify, that will tell us maybe, or inform what's in that landfill. So let's look upstream. This is what we decided to do. We basically asked ourselves the research question, if you like: can historical and geographical data provide a means of predicting landfill mass content? And this is Stephen Warwick's PhD, who was really kind of focusing in on answering this question. So what data do we need? Well, we need to know things about how much has been placed, sort of in an area or across a country or in a particular region. And for us to know that, then we can look at some of the things that we know. We know how many people there are, and we know where they lived. We've got reasonable good data on waste generation rates per person. So we know, kilograms per person per year. And we also have really fairly decent records of the amount of that waste that's being put into landfills. We can quantify how much has been placed into landfills. The other thing we need to know is, well, what's that waste made up of? So what's its composition? When it's placed, we need to think about how it degrades, how it's changed. Some things are inert, but there's lots of waste that we put in landfills that's not inert, and it changes into something else through various processes. And then the other big factor, often really quite tricky to get a good handle on, is landfill cover material. So modern landfills, almost all of them have some kind of daily cover. So we place the waste, and we put a layer of something on top of inert material to stop all sorts of health problems. But what that means is that the volume of the landfill is, maybe 40% of it is cover material. So that makes a big difference in terms of, if you think about exhuming it, taking it out to get value out, you're having to take out all that cover material as well as the waste. So we need to know about those things. We need to think about, well, what's the level of resolution? So are we looking at an individual landfill, or are we looking at the kind of like the national inventory? Are we looking at the southeast of England, or wherever it happens to be? And then if we kind of like have a go at doing this, then how do we check? How do we validate whether it's actually valid or not? What we've produced is any good or not? So what we've taken is what's called a systems dynamic approach, which is, it is an area of research, and it's a particular approach that you can take, but largely from someone that came from the era of doing everything in a spreadsheet, it's basically a set of, it could be thought of as just lots of really, neatly tied together spreadsheets. the software isn't a bunch of spreadsheets tied together, but in actual fact, you could do this in a spreadsheet, but it's quite difficult to do, and it's very difficult to manage the data effectively. But what we need to do is we can have this thing where we look at generates, we look at how many people are in a particular region, and that will give a daily rate, and then we can work out over a year how much is being produced in a particular region or area. And then we can start to think about, well, where's that gone? Has it gone to some other routes? And in the UK, not much of this, but has there been some recycling? Has there been incineration? If there's been incineration, how much of that is produced as ash? That will likely have gone into your landfill, and then the remainder then just gets directly tipped into the landfill. So we can start, if we can start to put data into these things, we can start to work out, well, how much waste is in the landfill. So if we look at the data we need, very quickly sort of canter through this, we need to know how many people there are. We know this pretty well, certainly in the UK, then the population has been recorded fairly precisely, and we know where they lived and geographically in the country. We know what kind of housing those people lived in, what economic status they were as well. So we can get really quite a good handle on what kind of waste they would produce. So the next thing, what's the generation rate? So these are average values for England, and you can see here that the generation rate, is progressively increasing. So almost doubled over the period that we're, this 50-year period that we're, 60-year period which we're considering here. You can see there's some noise, and these are for different reasons, but actually when we start to look at the data, we can be fairly confident we've got reasonably reliable values for these rates. The thing that we do know when we start to look at the data, and the reason that we've got good confidence of this, is that in the UK, then local authorities, have recorded a lot of this stuff. They've measured a lot of these things, and there's about 130 local authorities have recorded this data, which covers about half the population. So we've got really quite a good data set. We've got high confidence in the information. But what we do see is that it varies. Those rates vary quite strongly between areas. So if you're looking at a landfill that's maybe in a metropolitan area, then the rates that you need to be looking at are quite different than if it's in a rural area, or if it's in London, or if it's in inner London. Inner London is a peculiarity because lots of people kind of have activity there, but not many people live there. So that means they have, proportionally have, because there's not many people there, but there's lots of waste being produced. Their rates appear very high, but that's not that people that live in inner London produce more waste. It's just there's not so many of them, and there's lots of people that appear in inner London and produce waste and then go back home and live somewhere else. So in terms of the kind of generation rates that we get, this is what the results that we get back out of the analysis. So we put all that information in. Then these are the kind of rates that we see, these sort of million tons being produced per year. So this is, you can see, really quite strong increases over that period. We can sum that up to give us a total amount of waste that's been placed, and you can see it's not quite a straight line. The rate is increased, and we see the impact of that. So we've got more than 1 billion tons of waste has been generated in England in that period. So from 1945 to about 2007. So it's a lot of waste. So what does it contain? And where's it gone? So we can think about where it's gone by just looking at these kind of flows, if you like. And we know some of it's gone to landfill. We've got a proportion of, we know what those proportions are pretty well. As I mentioned, we've got the incineration that will produce ash, and we've got it going in different ways. So this is our systems dynamic diagram that shows where we deal with the data. The key thing is, what is the flow rate to these different parts, and actually there's quite good data related to that's available. When I say we, really, Stephen Warwick, who's the PhD student, has gone off and spent enormous amounts of time going through all sorts of records to identify what we know about these things, and actually the data is really quite rich. And what that means is that we've got really, sort of really quite a good handle on the proportion of waste, where it went, in which method it was used to deal with it. What we can see is that the landfill is kind of up towards this kind of sort of mythical sort of 90% value, but then really dropping off in the last 20 years or so, really coming down quite steeply, and that's been largely because of we're recycling a lot more than we were before. So of the 63 years we're interested in, 25 of them we've got numbers that we can put to them, and the other 38 years kind of like fall, sort of in between, so we can interpolate with reasonable confidence as to what values we should have. So we can feed these rates into our model, which can then give us some information about the amount of waste that's actually gone into our landfill. So this is our model results, if you like, of the tons per year, millions of tons per year being placed into landfills in England. And then we can see here, this is the total amount which has been placed over that period. So about 0.9 billion tons has gone into landfills, which is fairly close to our kind of 90% thing, which is where that value looks quite reasonable. Okay, so that's just kind of useful to know. We now know roughly how much has been placed in the landfills, and also, we can run the model at a very small resolution in terms of geographical area, so we can work out exactly how much has been produced in a particular city or particular part of a city. We then need to think about, well, what's that waste made up of, and we need composition studies for that. And the good news here again is there is actually quite a lot of information about what's made up of these wastes. It's a really unpleasant job. But if we think about what's going into our landfill, then we need to know kind of what components it's made of, what proportion is glass and which proportion is metal, and so on, and where are these things going. So what we find is just to give you some of a picture of some of the data that we have. You can see here, this is the kind of this is from 1960, sort of every decade onwards from 1960. But actually, if we look at the data before this, then the dust and cinders are a little bit higher in the preceding years, but largely this kind of figure. So really dominated by ash, and then the other components in this kind of form. And as time goes on, all of a sudden, everybody gets a gas boiler. They stop burning stuff in their fires, so the amount of dust drops right down. They then don't know what to do with their paper, packaging and card waste, so that then appears in the waste stream and sort of pops up, and the other elements that we might be interested in, often things that are going to break down and cause us methane, producible sort of waste. So you can see those developing here. We've got metals, which is the thing that kind of like tends to make us think there's value. They've been progressively appearing through each of the decades. Plastics, not recorded down here, but start to increase in quantities down here. Sort of 8 or 9% plastic in the waste stream. So when we have reports of there being 18 or 19 or 20% of plastics in a landfill's waste, it's hard to work out where it's come from. Okay, so these are the kind of latter years, what's happened in the sort of in the 90s, and you can see again quite a big increase in waste which is going to decompose quickly and produce methane. A decrease in the card content, then everything else staying sort of broadly similar to what it was before. Sort of graphically, we can show those kind of variations here. But what this shows us is we've actually got quite good data. We actually understand quite well how these things vary through the years, and we also understand how they vary depending on different locations. So is it an inner city area or authority? Is it sort of suburban area? Is it rural? There's a few places that are a bit different. Mining towns, the compositions are quite different. Seaside towns, quite different. But largely speaking, we can get quite a good handle on what the waste composition is going to be from a particular area at a particular point in time. So we can take all of that data together, put it into the model, and that starts to then give us an indication of well how much waste is there of the different components. So this, for example, is the results for the annual flows of metals going into English landfills, and you can see that, you know, sort of a bit noisy, but starting off very low, very little waste, and then gradually coming up in the latter years. This actually, you know, the area under the curve, if you like, is about 50 million tons of metal appears to have been placed into landfills. And, you know, sounds like a big number. I guess it's worth comparing it to something else that, you know, if you compare that to the weight of steel in all the UK cars that are on the road at the minute, that are registered at the moment, it's about twice the weight of all the cars, not all the steel in all the cars in the UK. So it's not an inconsiderable amount of material that's being stored there. If we look at the organic content, this one's of interest because this is what's going to be producing the methane, which is producing the emissions that we're really worried about. So what this does is start to give us an insight into the upper bound of methane generation, because this is all that's there. So this is what the maximum that our landfills can produce, because the carbon's not going to come from anywhere else. So that gives us a picture of what's in, you know, what's in our landfills. So we've established this model. In this particular instance, the results I've shown you have been sort of for England wide, but we can run the analysis very locally. So we can say an individual landfill was open between these periods. It's in, you know, it's got these characteristics. What's likely to be in there, and we can work out what those things are. Is it right? This is just the big question. As I'm a modeler by background, so, you know, validation is the key. You know, you can produce these fantastic models, but you need to compare it to something to check that it's actually reasonable. And that's quite a challenging thing to do because the amount of data that's available is relatively limited. There's some nice, you know, there is some data out there. There was some what they call the Manchester experiments undertaken in the late 60s, where they placed waste and then exhumed it. So there is some data there, and we've compared our models against that. Stuart Wugland's doing a really nice job looking at sampling UK landfills and getting some quite nice data from there. But it really is challenging to really have confidence in some of the fractions, because the sampling is so difficult to do. But again, we've made comparisons there. The one place where we don't do too well, if you like, in terms of comparison, it is the plastic contents. But if we compare the plastic contents to the waste, then, you know, what's sampled is hard to tie in. And then there's a couple of European projects which have looked at landfill mining. Particularly, there's this one here in Remo, and I'll show you the results that we get from that. So this site here is really quite a large site where they've effectively exhumed quite large volumes. So they've got, you know, relatively high confidence about what's in there, but they still get really quite high plastic contents up here. So we've fed in the Belgian data into our model, and these are the kind of results that we get here. So you can sort of compare the top and the bottom, if you like, to see how things are coming out. So we're reasonably pleased with this, in the sense that we don't know anything else about this landfill. We've not gone on there and done any sampling, but we can get a reasonable prediction as to what's in there. Certainly, if we look at in the kind of like the ranges of uncertainty there might be in the sampling, then we're kind of like, you know, very much where we would expect to be. The biggest fraction is the fines, and this is daily cover and also things that have been placed that have broken down into fine material. So the question, I guess, we were asking in the title of the presentation, is it all rubbish? And looking upstream really gives us quite a good idea, quite a good insight into what's in the landfill. The key thing is the data. How good is the data? And actually, I think, you know, as a modeler, we think about this quite, you know, rubbish in, rubbish out, and I think that the quality of the data going in is actually quite good. So we've got reasonable confidence about what's coming out. We've got uncertainties about how things degrade, because we've done people have done experiments, and we've done experiments in Cardiff about how, you know, paper breaks down and so on. And then you look in landfills and it doesn't do the same thing. And wood is a similar problem. So we have some uncertainties about that. And we have often there's poor data about the cover materials, how much was actually placed. And that obviously, if you're looking at things proportionally, 10% is this, then the amount of fines that have been placed as cover material makes a big difference. So in terms of the question we looked at, is there really value to be found? Then yes, I mean, there is value there. 49 million tons of metal is significant, but the volume of the repositories is really large. And that amount of cover material is a key factor, because if you're going to try and get that metal out in an active mining sense, then you have to process all of that cover material, and that's a lot of energy is going to be used. So going back to this modelling and sampling sort of question, what can we get from looking downstream? So I just want to quickly just look at, well, what can we find out from downstream? And I think that we sort of established relatively quickly that the idea of fingerprints to actually establish what's inside the landfill is going to be really challenging to do, very, very difficult. So if we're having this quick look downstream, then what are the emission, the emission rates? They can tell us, is it what's breaking down and at what rate. The leachates have the potential, I think, that to tell us if a specific component is there. Because if it's in the leachate, then it's in the waste, and that's useful. They've also got the potential to tell us the kind of like the phase that we're in terms of the landfill. But the problem with the leachate data that we typically have is it tends to be composite. So what that means is that because it's leachate samples are taken, as I mentioned before, because we're worried about the environmental impact of that leachate going somewhere. So it tends to be composite in the sense that it's been sampled, it's a combination of leachate sort of routes from different parts of the landfill. So it's quite difficult, if you've got a landfill that's been active, being in place for 20 years, then you'll be getting leachate from waste that's 5 years old, 10 years old, 20 years old, and it's all mixed together, and you can't like distinguish what's come where. The chemistry is fairly complex, and because of that, really, this kind of reverse engineering from the fingerprint is very, very difficult to establish content, and real huge uncertainties really related to the information that you get. But what it can tell us is a little bit about what's happening in terms of processes. So we've looked at this question. If we change what we put into the landfill, and in the UK we've done that, we've had the EU landfill directive has said basically you need to divert biodegradable waste away from landfills. So we've done that. What impact does it have on our landfills and the processes occurring in them? And how does it affect the leachate chemistry? So we've done some work on that. I'm not going to go through it in detail. There's a nice paper there that you can pick up and have a look at. But in essence, what it's done is it's looked at some example landfills where we've been lucky enough for the landfill owners to allow us to have the full leachate data of 2 landfills where the placement happened after the directive was put into place. And what that means is that the biodegradable waste content is dropped by about half. And we've got in that leachate data what we would call process indicators, so things that will indicate what kind of state the waste is in. If we look at how a landfill typically degrades, what we'd expect to see, this is the classic kind of plot here. From Christensen. So here what we can see is that we've got this these various phases. We have a aerobic phase where we use up the oxygen fairly quick, and then we have a anaerobic phase, which is really where all the action happens, if you like. This is where the methane gets produced, and lots of things are broken down. And in that, we tend to break that down into maybe sort of 2 styles, if you like. And we have a acetogenic stage early on, sort of a little sort of acidic, producing carbon dioxide. Maybe in the UK when this has been monitored, maybe first 3 years or so, that happens. And then what we tend to have is the methogenic phase. Oh, that's gone too far there. So it's just picking up to the fourth stage there, where we're producing methane, and the pH increases significantly. So There's some nice information from the literature. Eric sort of gave some nice ranges of the typical values for these process indicators related to each of the different phases. So we can look at the data and we can compare to see where we're at. So just looking at one of the sites, one of the sampling points for one of the sites. This is the pH. So this is the site this was a site that the waste was placed really from 2007 onwards. So which is really right at the beginning. It's just been placed, and the pH is up towards 7, which in compared to the kind of ranges we'd expect is right at the top end of the acetogenic, and really at the extreme end, because if it's acetogenic, you'd expect it to be slightly acidic, and obviously it's above 7. So we really, this is much more likely to be in the methogenic stage almost immediately. That appears to be what's happening. And when we look at the other side, we get a similar picture. If we look at the BOD, so the biological oxygen demand, which is another good indicator, then we see that very much the kind of values that we're getting in the site here for the various years where it's been sampled, very much down at the methogenic range, so very, very low values, which really indicates that in these sites where we've got this decrease in biodegradable waste, then we do get quite a significant change in the leachate which is being produced, and really an absence of this kind of classic acetogenic phase. And what happens is that the leachate signature, if you like, really changes very, very quickly to an established methogenic phase very, very early on. And actually, when you look at the methane generation rates for these landfills, that's reflected there. You get methane very, very quickly from these landfills, quicker than we would normally expect to happen. So what that means is that if you're a landfill operator, then we're going to expect to see a more rapid pathway towards methane production because of this change in the waste content which is going in. Okay, so just finally, what about in the future repositories? So can we have, and what we're thinking about in the ideas we're having in Cardiff is that there are some wastes that we can't incinerate or recycle. We need to store in some way. We need to dispose of in the old terminology, but can we store it? And actually, in that storage, is there some way that we can keep the elements of value that are in those wastes active within the circular economy? It's very difficult to do for some of the waste, because to actively do that is really intensive. To process them, it uses a lot of carbon, a lot of energy, a lot of chemicals. It's not sustainable particularly. So our thinking and our kind of approach to the problem is to look for a low energy, long-term approach. So time's on our side. If you've got a landfill, you haven't got to worry about things happening quickly. So can we introduce energy into the system to allow various processes to help? And so we've got a project which has just started this year, which is the Aspire project, which is where we're starting to look at these kind of ideas. And effectively what we're trying to do, the title of the project is Accelerated Supergene Processes, and supergene is the geological process which basically forms ores. And really, can we accelerate that process within a waste repository to effectively concentrate the elements of value, the things that we want, into a particular place to effectively form an ore, and at the same time, move things that we don't want out of the residual material, so we can free up this material for usage because it's no longer contaminated, and we can then produce an ore area or region within the repository, which we can then mine and extract the value. Obviously, it's not going to look quite like this. This is just a simple schematic which kind of like shows the ideas that basically we can introduce sort of energy. We can let water in, we can use sunlight, we can use plants to change the chemistry, to change the flow paths, to allow these processes to occur. I mean, really, that's where we see things headed in the next few years when we think about what to do with these wastes. Okay, so just to close, the question at the beginning is rubbish in, rubbish out, and we can think about that in two senses. One is in terms of the modelling, and hopefully you've got some confidence that we're not putting rubbish in, so we've got some confidence about the data that's coming out, or the results that are coming out of the models. In terms of the landfills themselves, then I think that that clearly it was rubbish when it went in, as it wouldn't have gone in. But what's coming out now, or what is there, does potentially have value. We just need to be very, very careful that we understand it fully to make sure that we do get if we do landfill mining, that we do get value from it. We've looked a little bit about the leachate development and future repositories. And so really, if we think about those questions that I asked, what is in these repositories? I think in terms of municipal landfills, I think now we've got a way of actually really getting fairly high confidence about predicting what's inside a landfill. We've answered that question. These are the ways we can find out. Is there value to be found? And then yes, there is, but it's quite a nuanced problem, and it's quite finely balanced as to whether we should really be actively mining these mining landfills, and we need to take into account the whole situation in terms of obviously the economics, but also the ecology and the social and cultural impact of these kinds of projects. We've looked a little bit about how they're changing, and then I've mentioned briefly about what's maybe the future for some kinds of repositories for some particular kinds of wastes, where those kinds of approaches may be of value. Okay, that's the end. You'll be pleased to hear. Many thanks. I haven't turned the chat on, so I'll have to have a quick look to look at the questions now.
Very good. Thanks a lot, Peter. So you can stop sharing, and I want participants to type their questions in the chat box.